Thank you for having me. My name is Hari. I'm a senior research fellow at the National University of Singapore. So as part of my job on the technical front, I work with oceanic engineering techniques, namely sound signal processing, underwater vision, machine learning, robotics, etc., to understand the ocean better. While there is this emphasis on the use of science to solve our problems during the ocean decade, I believe it's engineering and technology aided by science that will also implement these solutions and make the quantum leap. So on that front, as part of my job, I try to use sound to make inferences about the state of the ocean environment. I'm also involved as part of the IEEE Oceanic Engineering Society in various aspects of the ocean decade, like science communication via our communication magazine Earthzine, of which I'm the chief editor. I help organize student robotics competition as a way of engaging students and ECOPs in ocean engineering. And I helped organize several ECOP targeted programs at conferences. Like I organized recently the special session for connecting ECOPs to industry, academia, and so on and so forth. I did a decade outreach booth at a recent Oceans conference to spread the word on the ocean decade to more of our OES members. So these are some of the activities I involved in.
Amazing. Thanks so much, Hari. So I just want to touch on your research area, so ocean engineering, but specifically acoustics and sound. Just wondering what drove you to study this topic and what are you hoping to achieve personally and also in this wider scope of ocean science and discovery?
So how I got into acoustics and robotics? Well, the importance is probably explained that the ocean is very vast, as we all know, and we keep hearing more often that it's pretty much underexplored as compared to, say, something as distant as the moon or Mars even, which is kind of surprising to many of us. And only about 23% of our ocean's depth is mapped. But how do we begin to monitor and sense such a big entity in the first place? Light or electromagnetic waves don't travel much underwater. So pretty much our best medium to get a window is sound. It travels longer distances underwater, so carries more information. So how I got hooked on, well, I was into signal processing during my engineering bachelor's. And then I realized this could be put to good use in sensing something much bigger and covers 70% of Earth's surface, right? That's our oceans. And that's what got me into doing my PhD 13 years ago. So I studied noise produced in Singapore waters for a while. And that's produced by large colonies of this creature called the snapping shell. So that's what I was involved in for a long time. But then then I ended up with some part of Arctic acoustics, and that's a weird connection. Once we met folks studying glaciers in the Arctic, and they described the sound of glaciers of Svalbard, and the description sounded like the same we have in Singapore. It was kind of an uncanny relationship. It also is a crackling sound with kind of the same statistics, except that in the Arctic, that sound is produced by a different mechanism. That's because of bubbles bursting out of melting glaciers. So we figured out that Singapore and Arctic, they are worlds apart in terms of climate, latitude, whatever you have it, but they have that uncanny link in terms of underwater soundscape. And so we decided to study these melting glaciers to see how sound can be used to estimate how fast our glaciers are melting. And that feeds directly into our understanding of climate change and things like that. And that's part of my aim here as almost a personal achievement. I would like to see how acoustics can be used as a tool to understand these things better and feed into our understanding of climate change. And likewise, I also use sound to study marine organisms because the climate change affects all marine organisms. And it's evident that at the top of the ocean food chain, you will find apex predators like dolphins, for example. And it turns out that we have some dolphins in Singapore as well. So dolphins are a good indicator of how healthy the ocean is in a particular region. Like for example, Singapore, we would like to know how good the environment is. So what's the best way to study a pod of noisy dolphins who you don't know when they're coming, when they're going, they're somewhere in the water, hidden away, they might surface once in a while? It's sound, again, because they make sound. So I got involved in this exciting field of dolphin bioacoustics, applying some local domain knowledge and machine learning to look at the diversity of marine mammals. And that's also an exciting part of my research.
Okay, we're going to move on to the IEEE Oceanographic Engineering Society. So perhaps you can tell us what that stands for and also what you're doing with them and why this society might be of interest to other ECOPs as well.
So IEEE, as we call it, is the world's largest technical professional society. it has around 500,000 members, I think. So it's fairly huge. And Oceanic Engineering Society, or OES for short, is just one wing of that, which deals with oceans and ocean technology. And OES has existed for long. It has been organizing ocean tech-related conferences, webinars, helping with establishing standards, public outreach, etc. So what our link to the decade is that we see that OES is a natural bridge between this large global movement we are calling the Ocean Decade and this large professional organization of engineers named IEEE, because there's a good, we can apply a lot of engineering techniques to the decade, and it doesn't necessarily need to be limited to a specific domain. And in terms of the decade itself, OES has been involving a lot by promoting ECOP involvement for some time. There has been this focus on getting young blood and energy in the forefront via this program called Young Professionals. And I'm a volunteer at OES, and I also sit on the administrative committee of OES starting now in a month. And that I think that means quite something, because I'm allowed to be part of this leadership of such an esteemed large organization. And they also have an award to encourage youngsters to join the society and take part in these outreach events called Young Professionals Boost. So other ECOPs may want to look into that. It also comes with a travel grant. And I was one of the earliest awardees in 2019. And as I said, I also head their science communication magazine, Earthzine. It's actually a OES science communication magazine. And as part of that, I had started helping with organizing student robotics competitions also, which is something OES is involved with all around the world. There are like a few of them they organize around the world. And that has been very personally satisfying for me. And I think from the way I see my fellow volunteers enjoying at these events, for ECOPs around the world who really want to get involved with a truly impactful technological education activity, helping run such events would probably be something that interests all of them.
Great. Yeah. So let's talk a little bit more about that and what's been happening with the student AUV competition. So you were the one organizing it in Singapore this year. So I didn't realize they would take place everywhere as well. So yeah, tell us about the one that you've been involved with the most.
Yeah, there are a few of them worldwide. I don't think they change location, but the one in Singapore keeps happening every year, except the last 2 years, which COVID obviously got in a mess. I organized, so Singapore AV Challenge. And I want to mention that I'm part of a large volunteer group that helps organize it. I don't do it by myself. It's a large event, and it can't be done by one person. There's a lot of enthusiastic volunteers here helping with this. SAVC, as we call it, is the largest ocean robotics competition, student robotics competition in the Asia Pacific. It's huge, and this year it was even endorsed by the UN Decade. This year we had 25 teams and about 300 students attending, and it was like a 3-day festival of robotics. Students just walking around building these amazing underwater gadgets that can perform tasks in a swimming pool, do some neat, cool stuff like acoustic localization or vision and things like that. And then they figure out what's going wrong with the electronics if they have issues, and they take excuses to jump into the pool and test it out. And there's a lot of competition, but there's also a lot of collaboration and networking and excitement going on. And a lot of countries are represented at this event. So that's something we are really excited about. We have, well, at least this time, over the years, we have had teams from, let's start from the West. We had US, Canada, Turkey, Russia, China, India, Pakistan, Bangladesh, Sri Lanka, Singapore, Malaysia, Indonesia, Thailand. And I'm sure I'm missing a few of them. But anyway, so some of our earlier challenges involve getting the excited teams to turn up, but now they turn up in large numbers. So now our main thing is to make sure it all goes smoothly. Having 300 students in one dense area is not easy. And at one point, we have to send out a lot of emails, but we make sure the event is fun, teams are having fun and learning. And we also have workshops and seminars as part of it to give the students another educational element to it. So I think we've developed good expertise and a good team to handle this over the years. And this year it was quite fun.
Amazing. It makes me, it's great that you've got the visual in the background as well.
Yeah, that's one of the team robots up there.
Yeah, because for people who are, for me, I guess, working in ocean literacy, it's something you don't really think about, these autonomic machines and robotics. And as a kid, we had a TV program called Robot Wars, and it was so awesome to watch and to know that now this is being applied.
Something like that. You could think of it that way.
Yeah.
Exactly. You could think of robot wars, except the fact that they don't have to beat each other down, but it's pretty much that. And it's hands-on education, right? That's exactly what it's about. You learn by doing, and then you figure out things that you might not have been taught in textbooks. We see a lot of that happening. So that's fun.
Yeah, great. And so you already mentioned it, but how this is going to be a really critical part of the next stage of ocean discovery. And so what would you say to ECOPs who are thinking, oh, maybe this is an area that I could be interested in? How would they start to get involved in it? You already mentioned volunteering with the events. Would someone just start tinkering around and making their own machine, or are there other sort of ways in? Can you do a specialized course? Yeah, or maybe from your experience, how did you get into it? And I guess there's certain levels of, like, could one person make a machine like this in the background on their own, or do you need a whole team to be able to develop that?
Yeah, so I would say individual effort is not going to be easy to pull off a whole working robot, because there are so many dimensions to underwater robotics. It doesn't stop with just building a robot. You have to make sure it's buoyancy is right, it's waterproof. The most important thing, you don't want your whole robot electronics drowning in water. So keep making sure that it's done takes a lot of time. Once you put it in the water, things don't work the way you want. It's a 3D world, so it's not something it's not intuitive for us. You have to take care of depth and buoyancy, and those are not things that come naturally to humans, at least unless you're used to things like diving and so on and so forth. And so how would teams get involved? A lot of teams that actually turned up, they sprung up organically. We asked them what interested you. They say, oh, we had robotics going on, but we thought this is an exciting place where we could use robotics. And in fact, that's exactly the way I felt about it too. I mean, we can't sense the whole ocean using sound alone. You need some sort of in situ or direct like intervention. That's where robotics comes. But I'm sure there are courses out there. I haven't really done a check on Coursera myself, but we have some learning materials on our website, like a robotics primer, so to speak, to get teams started with. And that tells you kind of the basics that you need to be aware of. And that, but at the end of the day, it has to be a large enough team that covers mechanical, electrical, acoustics aspects. In fact, teams, if they want to sustain, a lot of teams even have a publicity team, right, that does outreach, gets funding, because you need to sustain it. There's sometimes funding is an important thing. They have a lot of wings to them. So the good teams have actually gone on to build a whole structure, and then they have this recruitment drives where they get juniors coming in and learning from the seniors and then carrying it, so on and so forth. So we see that that's what really works. And the other thing would be, once you turn up at the event, you can learn from the other teams. And a lot of the new teams who came up first time or something, they might not even have been successful in putting their vehicles into the pool. Or if it went into the pool, they would have had a heartbreak that, oh, it didn't move or it flooded or something. But nevertheless, they learned from the other teams and took back from them what worked and what didn't. And we have seen so many teams that have come the next time and gone on to win the whole thing. So there are so many teams that said, oh, we learned from that team last time, and now we think this is what works. And they've gone on to many other competitions in the US and so on and so forth. So many of the success stories, we feel they started from such simple steps. But we also had very simple teams. Like we had a small high school team once come with something like a Tupperware box, and even a girls team, that small secondary school team that came with a Tupperware box that had wings, and they just put it in the water and made sure it goes in one forward direction, but they ended up getting one task right, and that was good enough for them. So you got to start somewhere.
That's amazing. So it's not about necessarily winning the competition. It's actually using this space and all these networks and all these minds coming together to actually develop and grow, and just get inspired to and find solutions. So that's a great learning opportunity as well.
Absolutely. That's the way we want it to be.
Great. Okay, so we'll just shift over then to the magazine as well that you're talking about, Earthzine. So this is more about science communications and more of a traditional way of talking about science. So how did you get involved with this? And is there ways that other people can get involved as well? I did notice that you accept admissions, so people could submit something. So let us know about that.
It's the SciComm magazine of IEEE OES, and it was previously run by NASA, but then OES took over. And there was this revamp in 2019, and they were looking for an ECOP to head it. And that's when I took over as chief editor. And we revamped our website, changed a whole bunch of things about how we publish and so on and so forth. And since then, we've been seeing an improvement in our readership in 2019. Earthzine is 99% run by ECOPs, by the way. And I think that's a major feat. The editorial team and website team, all ECOPs. And we have about 200,000 page views a year, if my numbers are right, and about 60,000 users who come read stuff from the website, to put it in perspective. So it is a large website that started from a long legacy, and it's still going on. And both our viewership and users are increasing year by year. So we're happy about that. And search engines are beginning to feature articles more. So it came from our idea for Earthzine is that science should not necessarily stay stuck in academic papers out of the reach of people who don't understand technical jargon. It can be simplified. It should be simplified. It needs to get out into the public to let them know how they are being affected by science or what ocean research translates to for them. And that's also an important part of the decade, right? Making the common man or woman aware of what it means for them. And science communication is even important, for example, geopolitically. Like it's an important aspect, for example, to a government to justify to the voters where the public taxpayer dollars are being poured into research. Why are we funding research? So public needs to know what that science is doing for them. And in 2020, for example, Earthzine did special theme on the themes. So we do themes that are of upcoming interest. For example, in 2020, we did a plastics in the ocean theme, which I think we all know is now the big issue. And we had about 8 to 10 articles on that. And I think that was successful. Now, 2021 onwards, we have this big theme going on about the ocean decade. So we have an ocean decade theme running. So to answer your question, yes, anybody can submit articles to the theme. It's currently open. All we do is we make sure that your technical sources are verifiable and that you have enough accessible language in there, you have images, and then anybody can contribute. The link is up on our website. Likewise, we are also currently open for people who want to help with reviewing it. It's not a technical peer review. It's let's say a copy editing review alone for language and things like that. And I think anybody from in any field can do that. So we are open to people applying and helping out in that, volunteering to help spread science communication. So those who are passionate about that, please do look at our website.
Just to kind of come back around, like, what are your hopes for the next year of the ocean decade? Are you continuing? You're doing a lot. Are you continuing with all of these roles? And how can people get involved, reach you, support you? And what would your final message to ECOPs be?
So to answer your first question, yes, definitely planning to continue with the decade. I plan to continue with it. I mean, I want to continue in ocean engineering as a career itself. So I don't think I'm ever going to go away from the spirit of the decade, but the decade itself, we are planning more OES thrust in this area. IEEE Oceanic Engineering Society is hoping to become an implementing partner. And as you know, we even participated in the recent United Nations Oceans Conference. That was an effort to reach out to more like-minded folks and maybe put together sessions in upcoming ocean-related events around the world. And not just the conferences we organize, but related conferences. So that's how we started doing similar themes in Ocean Sciences Meeting and other conferences. But we want to make sure our OES members are also more well-informed. So we had a couple of booths recently at one of our conferences. For people to sign up, well, like I said, for Earthzine, I invite anybody to apply to be a reviewer and help review our articles. It's always great to have energy on that front. In terms of student robotics competition, well, we invite everybody to spread the word on SAVC. And if you're in Singapore or nearby, you can help organize even in person. We would really love help on that. But even with respect to publicizing it wherever you are, that would be great. Or participating or forming a team, reach out to us. We are always accessible. We try to keep it as accessible and like a community event as possible. For IEEE, you can join as a member and you stand to benefit from a lot of the networking, but you can also help with many of the events or by attending IEEE OES conferences or tapping into the various technology committees and networks that they give you with. So we have technology committees that cater to specific fields. And we have 2 Oceans conferences per year. So the conferences are also called Oceans, by the way. So that would be another way for ECOPs to be involved. And ECOPs should definitely check out our Young Professional Boost program. It also gives you a travel grant, and it's one way you can try to help with the leadership level of the society. Maybe you want to help steer the society more towards some decade events. And we are also having this thing where we are trying to take up some very important technology areas. So I feel the decade has reached a point where we've discussed enough about what we need to do. We've identified it. We've gotten the networks sort of set up. I think, of course, networking can never stop, but we have the communication channel set up. It's time for us to do some of that. And many of us have already started doing that, right? But how do we do that? Now, the next thing is we need a big leap in technologies. It can't be like small bits every year like it was beforehand. We don't need a decade for that, but a decade is to make big leaps. For that, we need to look at ambitious technologies and very forward-looking technologies. So with sort of that in mind, we started organizing this series called Design the Future Ocean Workshops, where we try to look at upcoming technologies, get the people who are passionate about that, but they haven't had a chance to publicize their ideas, but they want to get more people involved, get them together, get them talking, see what they need, put them in touch, and get that going so that in maybe a couple of years, we are in a better position to start implementing those technologies.